Welcome back everyone to another video. Provide the hybridization of each carbon atom and approximate the bond angles of the given molecule. We're given our structure and we want to recall the basics of the VSEPR theory. The theory allows us to relate the steric number to hybridization, electronic geometry, and bond angles. So we're going to redraw our structure. First of all, we have our CH3, which is a methyl group, so we're going to say H3C to show the correct connectivity of the carbon atoms. Then we have CH2, so we're going to say H2C. Then we have our CH, so we're going to say HC. We're going to introduce that double bond between our carbon atoms and we're going to say C. Then we're going to add hydrogen below that carbon. Then we're going to add carbon with another hydrogen. Then we're going to introduce our double bond. And then, of course, we're going to say CH₃CH₃ because that's what we have at the end. So now, first of all, if we expand our bonds, we can say that the first one is our methyl group. We have carbon with 3 hydrogen atoms, which is bonded to another carbon with 2 hydrogen atoms. Then we have another carbon, which is then double bonded to another carbon. We're going to add the missing hydrogens. Now let's introduce our single bond, our double bond, and the final methyl group. And now let's add all of the missing hydrogens. Okay, well done. So now we have depicted all of our carbon atoms. We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 total. And each carbon must have 4 bonds. So starting with the first one, we notice that this carbon has 4 electron regions, or basically 4 single bonds, which is represented by a steric number of 4. So we can say that the hybridization for a steric number of 4 will be sp3. So we're going to say this carbon atom is sp3 hybridized, and the bond angle would be 109.5 degrees. So 109.5 degrees. Now considering the next one, from the CH2, it has 4 single bonds, so the steric number is 4. And that means we will have exactly the same scenario. We can say that this carbon atom is also sp3 hybridized with the same bond angle of 109.5 degrees. Now for the next carbon, we notice that we actually have 3 electron regions because we have 2 single bonds and 1 double bond. So for 3 electron regions, the hybridization will be sp2. We're going to say that the hybridization is sp2 and the corresponding bond angle is 120 degrees. Moving on, we notice that we have another double bonded carbon. So we have 3 electron regions as mentioned before. And it essentially means that we have another carbon which is sp2 hybridized with a bond angle of 120 degrees. Now the next carbon is also double bonded, right? So it has 3 electron regions, meaning we once again have sp2 hybridization with a bond angle of 120 degrees. The next carbon is also double bonded, so it has 3 electron regions, 1 double bond and 2 single bonds. So it is also sp2 hybridized with a bond angle of 120 degrees. And the final methyl group, considering that carbon, it has 4 single bonds with a steric number of 4. And that means we have that tetrahedral geometry for the sp3 hybridization. So that would be sp3 with a bond angle of 109.5 degrees. And that will be our final answer. We have successfully assigned all of the bond angles and hybridizations. Thank you for watching.